Hi, I'm the author of RadGEEtoolbox. My name is Mark Radwin. I'm a PhD candidate earth scientist who uses a lot of satellite imagery for my studies, and I've put together this package to really organize a lot of the functions that I've come up with and make my own workflow very much more efficient and quick. And I wanted to share it with everyone else to be able to use it because it really minimizes a lot of the code needed to do a lot of different processing. It makes it very quick as it's server-side friendly. And I really don't know of other packages out there that do really what this does. There are some similar tool sets out there that offer some different functions that you can use on Google Earth Engine, image collections, or images. But the workflow is a little bit funny with them, and I have a lot more functionality with this package that I haven't really found elsewhere. So hopefully an assorted group of people and students and specialists might find this useful and cool. But to install this package, all the information needed should really be available on my README here on my GitHub. And I have a documentation page that I'll kind of get into a little bit later. But to install currently, it's only available from pip. So you can just say pip install RadGEEtoolbox. It only has one dependency, being the Google Earth Engine API. So there shouldn't really be any conflicts with your virtual environments. But soon it'll be coming out on the Conda4 feedstock. Right now it's just in review, so hopefully soon it'll be available from Conda. On my GitHub page here, I have a folder called Example Notebooks. This outlines 3 different notebooks going over some different functionalities of the package that I'm going to review in this tutorial. And then moving forward, I hope to make some other short tutorials that I'll outline different functionality that might not be so clear. You know, I'm an earth scientist by day. I'm not really a developer or programmer. So, and I'm kind of mainly just self-taught. So I don't really have a lot of the best practices per se, and my documentation may not be the cleanest or most understandable, so I apologize in advance. But that's why I wanted to make these videos, to make it clear my intentions behind the package and how to use it. So like I said, if you click the documentation page, I have documentation available from Read the Docs. And if you click on one of the classes, one of the modules, and there's 5 modules I'll go over, you can see all the different attributes, property attributes, and method functions and static method functions available. However, there's a lot of overlap, so I wanted to make that clear in this video. So I'm going to go over the example notebooks really quickly, and then make a couple other short tutorial videos going over like my workflow and some other things. So this is the first Jupyter Notebook example that I have, called the Collection Definition and Filtering Notebook. Shown here is just kind of how I ran the import Earth Engine, import from RadGEEtoolbox, import the necessary modules in this instance. And in this instance, we're going to be importing the Landsat collection and Sentinel-2 collection modules. These 2 modules really give you all the tools needed to acquire and process the satellite imagery from the collections, and the rest of the modules are really for some accessory things and image visualization. So of course we need to import them and then initialize our project with Earth Engine. And then once we do that, I want to just now go over defining the collections. So in defining the collections, there are just a few requirements that you need as arguments, being of course start and end date. We want to set the time scale of the collection that we want to acquire from Google Earth Engine. Then we want to say where, and there's a couple methods on saying what images from where on the planet you want to acquire. We have the first option is using a tile. So shown here, we're going to start with using the Sentinel-2 collection module, and Sentinel-2 uses MGRS tiles. The swaths from Sentinel-2, as they come down from their orbit, they're about 300 kilometers wide, but they break each swath up into 100 by 100 kilometer tiles. And you can learn more about these tiles. I'll post these links in the description, but there's a page here that they have the KML file to look at the grid for Sentinel-2, and I can open that up in Google Earth. And that's what this looks like. So these are all the MGRS tiles. If you're going to click on one, it would show you the name. So this name is 29QMB. But in the case of the notebooks here, I have some tiles covering the state of Utah where I live, and I wanted to use that as a quick example. So in this first example, this first collection, we're defining a start date and end date, and the start date has to be in this format where it's year, month, date with dashes in between. If not, you'll get an error. And then we can specify the tile as a string. But note that if you want more than one tile, you can do that. You can provide more than one tile as a list here within brackets. There's another way we can filter Sentinel-2 collections and Landsat collections other than tile. We can provide a boundary or geometry. It has to be an Earth Engine geometry. So you can upload shapefiles as an asset to Google Earth Engine, or you can use available, or you can define a shapefile, boundaries as an Earth Engine geometry, or you can use already available geometries within the Earth Engine catalog. But I think a really useful way to filter Sentinel-2 imagery is by orbit number. They offer this, and that basically just gives you the whole swath for a single day. So you can provide one orbit number, or you can provide a list of orbit numbers, and you can also provide boundaries as shown here, which is basically the geometry. So in this instance, I'm showing the county of Salt Lake City County, and we can filter by that area, so I'll just get tiles that intersect with this boundary. Additionally, we can filter the collections based on cloud percentage. So there's an argument called cloud percentage threshold that you can set to only get images with percentage of cloudiness in that scene equal to or lower than that number. Same goes for, there's a no data argument. Sometimes a lot of these Sentinel-2 tiles will have a lot of no data pixels. Either they're on the edge of a swath, or there's something else that I actually totally haven't figured out what's going on with some of the images. But they actually have a metadata parameter for that. So you can select images with a certain amount of percentage of no data in the scene. So in this case, for this low clouds collection, I have defined start date, end date, said let's go by orbit number, and then we defined, okay, let's only get images with 15% or less clouds in the scene. And then in this collection, that I have shown that you can use the no data argument to get images with 15% or less no data throughout the scene. So hopefully this kind of shows some of the different ways you can go about filtering these collections, and you can do it in just one line rather than multiple lines of code. So that just defines the initial class. So no processing happenings when we initially define them, but shown here is an example. I'll go over some more of these, but this is a property attribute that if you just put .dates, you take a class object and put .dates, you'll get all of the dates of all the images in that collection. So if I run this, it shows all the different dates, and you can see there's a lot of overlap because we picked S2 col right here, and this has 3 different tiles. So this is showing that a lot of these tiles are from the same swath, so they have the same date. And I'll in a little bit show how we can then mosaic those images. But next I want to quickly go over how to do this for Landsat. So similar thing, you would just say Landsat collection, you define start date, end date. But in this case, since Landsat doesn't use just a single tile name, if we were to go look at the tiles for Landsat, we would click on one, we'd see that each tile has a path and a row. So with the code here, we would define the tile row and the tile path. And it's similar to Sentinel, where you can define it as a list if you want to define multiple rows or multiple paths, and that will be included in the filter. And again, we have other ways to filter it. The only difference between Landsat collection and Sentinel-2 collection is that there's no way to filter based on the swath, so there's no relative orbit number, and there's not a no data filter. So you can't use those to filter Landsat collection, but we still have cloud percentage threshold. So in this case, looking at just 50% or less clouds in the image. And again, though, you can use a geometry or a boundary to filter your collection. And again, just kind of showing if you were to turn the collection into an Earth Engine object, which using this .collection property attribute, we can get the info of it and as an image collection object, as an Earth Engine image collection object, and see all the properties. But like I said, before, we have these class objects. So if we were to just print the data of this one collection of a Sentinel-2 collection, it just shows that it's a RadGEEToolbox Sentinel-2 collection object. But as I said, as I showed up here, you can quickly go back and forth between class objects and Earth Engine objects. So this kind of leads to the general data management side of things, using attributes and property attributes. This is really, I think, the bread and butter of this whole package, is using the property attributes, because they make life just really easy. But there's plenty of methods if you want to specify things like thresholds and other aspects. But here we can see that kind of going into deep depth here now, showing that if you use the .collection property attribute, that'll turn it into an Earth Engine collection rather than a class collection. But you can go back and forth. You can take that same object that we just made an Earth Engine collection and feed it in as an argument called for the collection argument. So with the Landsat and Sentinel-2 collection classes, for the arguments, if you specify collection, that'll override all of the other arguments, because you're basically giving it a collection. You're not trying to define one, and you're turning it into a class object. And then from there you can run with it, and you can then use the property attributes as shown here. So there's the dates property attribute as well, which gives you a client-side list, or there's the dates list property attribute, which gives you a server-side list. And then there's some other things you can do, like use the mask clouds collection or mask to water collection to then just take that collection and give you the same collection but mask out all the clouds, or take that collection and mask 2 water pixels. So if you want to just look at water, then you can really easily do that. And just running this, it shows that that first collection was an Earth Engine image collection object, but we turned it back into a class object, and from that class object we then were able to get the lists again, but also have an EE list for things if you want to iterate on later. So that's of course not going over all of these, so that's why I want to make some more videos to really illustrate how to use all of the different property attributes. But then we have methods. So these are basically functions that builds off of the class object, but you can specify another argument. So in this case, if you wanted to mask to water collection but use NDWY to mask to the water, because up here this mask to water collection uses the quality bands data, which is already processed to basically state what the pixels are in the scene. But if we want to use NDWY instead, we can, but we have to provide a threshold for masking the NDWY data to then mask the image. And so this shows some examples of we can filter, where we can mask the collection based on a polygon. So of course you would need to provide a polygon. So this is a method function. So we would just write adds on right into the class. We put dot mask to polygon, and then you would specify the geometry you want to use. So then all the images will have just the extent inside that polygon. Or there's a great this is actually a property attribute called mosaic by date, and this allows to mosaic all the image collections, or all the images in the image collection by date. So if you have images that have the same date, it'll mosaic them all and turn it into just one image instead of multiple. And here's the regular masked water collection, but if you want to use NDWY, like I said, you have to specify a threshold, and that'll mask the collection to water, or it'll mask this. These actually mask out water. There's masked to water and there's mask water. The masked water collection will mask out water, but the masked to water collection would include water, if that makes sense. And then you can chain the methods, so you don't have to just do one-on-one line like I'm showing here. You can take the collection, you can mosaic it, you can mask it to water, and you can process its turbidity all in one go. And then from there we're saying, okay, what are the dates of these mosaic turbidity images? And we can see that, okay, there's no overlapping dates. All the images have been mosaicked into one image per date. So that's really cool because that's just showing you that what would previously take, lots of different defined functions and multiple lines of code, all in just one line of code, you're mosaicing, you're masking, and you're applying a multispectral function. Then we have another method function called image grab. This basically, if you want to select an image from the image collection, you can do this by index using image grab. So in this case, we're getting the latest image in the collection. But if you want to pick or select an image based on the date of the image, you can use image pick. In this case, I'm just getting the last date in the dates list from this collection. But you can, of course, just say whatever date from the image collection that you want, and that'll grab the image. This also makes it easy if you wanted to iterate through the images as well. And this is just showing that when we get an image, it's giving us an Earth Engine image. It's not a class image, if that makes sense. So we can just say .getinfo and get the image, the information from that image. In this case, it shows us that the band that has all the bands, not just a turbidity image anymore. And then we have static functions, and these functions are to be used on Earth Engine objects rather than class objects. So in this case, we're showing that we can take a class object, turn it into an Earth Engine object with .collection, and then we can use these functions because these functions are supposed to be meant to be used on Earth Engine objects. So this basically is saying you can use these functions on objects that you didn't get using these classes. So these functions are still very useful. You don't have to have a class object to utilize these functions. And this is just showing the image data, which puts a date attribute as an image property for each image. And then this is showing that the function for masking water is called mask water S2, and you can apply this to any Earth Engine object. And then we have a way to calculate the pixel area of pixels of interest. So for example, let's say you have an NDWI image and you mask out all the pixels that aren't water, and then you want to calculate the area of water in that image. So this allows you to do that. But you would have to provide the image as an argument, the band name of the band that you want to be using to calculate the pixels that are non-zero, or the real pixels, and then you can select the geometry. So inside that area, it'll calculate the area with the pixels, and you can set a threshold. So this is useful from the NDWI image. You can actually set the threshold to use that above or below that threshold that you don't want to incorporate in the area calculation. And then you can set a scale for the pixel size of those of the pixels in the image to sum up. And this is showing that if you run that in 6 seconds, it calculates the area for this big area, the water area, and this big area, and this big image. And then similarly, you can do it on a full collection. And to do it on the full collection, showing here that we have the mosaic collection. We're using the NDWI property attribute, so just .NDWI, so that's making an NDWI collection. And then we run this pixel area sum collection property or method, and we specify the band name, the geometry, threshold, and the scale. And this does it for each image, and we can do an aggregate array, .getInfo, and we can see all the different areas of water for these images on different dates. So that is the first example of how to define and filter image collections using these classes, and the various different ways you can use the different methods within these classes to get basically to the same things. Next, I want to talk about using some of the multispectral functions available. So first we'll import, select kernel, and like I was saying, there's a lot here. There's a lot of property attributes, and a lot of them do multispectral processing. So we have NDWI to mask to get to water, we have NDVI to get to vegetation, we have LST to get to land surface temperature, and we have some multispectral indices that I've published on mapping halite or gypsum in evaporite basins. We can process a whole image collection to just get the max pixel value from the whole image collection. We can get a median image from the image collection. We can get a mean image or a min image. We can process for turbidity using the normalized difference turbidity index. We can process for chlorophyll A or relative chlorophyll A concentration, and turbidity also is relative turbidity. It's not, a calibrated value. However, all these multispectral products are able to be easily called with property attributes. So shown here is basically calling a lot of them. We define a quick collection from Landsat collection, start date, end date, tile row, tile path. Again, in the Salt Lake City area, or just Utah area. And to make an NDWI collection, it's easy as .ndwi. To make NDVI, it's easy as .ndvi, yada, yada, yada. Same for LST. For surface temperature, it's just collection.lst. So that does the surface temperature collections using the thermal bands right then and there. And then this is just getting some information from them to kind of just show that, okay, once we process them in 0.5 seconds, we have bands with the band name NGWI for the NDWI collection. And for the surface temperature collection, the band name is LST. And we can see all the image metadata and properties. Same thing for temporal reductions image collections. You just col.mean, col.min, col.median to get you to any of those sort of associated image collections. And if you were curious what the mean relative chlorophyll concentration was in a water body for a certain period of time, you could define that collection and then just do .mean, so very easy. But yes, this states here that note that by using these property attributes, you're not really masking the images. You're getting a full collection where the threshold for masking is -1, and since those multispectral indices are normalized, it's just not masking anything. But you can use the method functions associated with each of these attribute properties to specify your thresholds for these calculations and to mask out pixels that don't meet the criteria of being classified as that surface type. So if you want to map water pixels and just water pixels, you could say run NGWI collection and specify a threshold. I have failed to tell you guys that one of the really cool aspects about the Landsat collection class is that it utilizes Landsat 5, Landsat 8, and Landsat 9 imagery all into one collection. But since there's some radiometric differences in the sensors, what you can do is you can specify a threshold to be used for just Landsat 5 and then a threshold for next generation threshold to be used for Landsat 8 and 9. So this is really useful if your image collection extends back, let's say, to the 80s where it incorporates Landsat 5, and then you bring it forward to where we're only having Landsat 8 and 9 imagery. So you can specify different thresholds to be used. So that's really helpful. And here's some examples of that where we can create an NGWI collection as we did before, similarly at least, but we just call NGWI collection and we have to specify the argument of threshold. So this will mask all pixels with NGWI value less than 0. Same for NDVI, similar thing, really similar thing for any of these. And this is an example of the next generation threshold. And you run that, print it, verifies with us that had NDWI, NDVI, turbidity, and so on. So hopefully that makes sense on how to use those. And then again, we have static methods. We have Landsat NDWI function. This will take, rather than self, it takes an Earth Engine object or an Earth Engine image as an argument. So you can map this function along a Earth Engine image collection. And this kind of just gives that an example. So we just turned one of the class collections into an Earth Engine image collection, and we mapped this function across it, where since we have to specify a threshold and image, we have to use lambda. And lambda just says that, okay, on this map, take self as the image argument, and then we can specify a threshold later. And that works as well. So hopefully that makes sense. As a quick demo on how to use the multispectral functions and what kind of capabilities we have here with all these different functions to map surface types. And then you're probably asking, okay, but I want to see maps, I want to see cool, fun data. So similar approach here, we'll just import packages, and this is the palettes and visualization notebook now. And there's two different modules that I haven't talked about yet, called the get palette and visparams modules. Get palette module basically allows you to easily get a palette of like a hex palette of colors, and we have a list here. These I'll post in the YouTube description where the source of these color palettes are from, but there's some great color palettes, and this makes it easy for image visualization. But we can see that we have a visparams module as well that incorporates the get palette functionality. So what we can do is use that visparams function and class at least, and there's a get visualization params function. What we have to do is specify the satellite, either Landsat or Sentinel, because the band names will be different depending on what sensor you're using. And then we specify the index. So basically, what are we going to be visualizing? So this shows that if we wanted to get the visualization parameter dictionary for true color Landsat imagery, this is what we would have to specify. I really made this just because I don't like working with the dictionaries. I think they're kind of a pain, and I always have to go back and get the palettes and stuff. So this just makes it really easy to just bring in all of the different necessary information to, using a function to get a visualization palette. And there's extra ways to customize these visualization parameters. You can define a new min or max value or a different palette. So it makes it pretty easy. And if you were to just run this, it just shows here that you actually get a dictionary as a return rather than just the function. So putting it all together, define an easy collection. So this start date, end date, rows, and then path and cloud percentage threshold, and we're mosaicing each image that has the same date, turning NTWI. Let's also make LST. Let's also make a mean LST image, and let's print out the dates. So really quickly, we get all of the dates of the images in this time frame, and then let's map, let's visualize a true color Landsat image for the latest image in that collection. Now this brings me to a perfect point to shout out to the Geemap package. This package is amazing, and if it wasn't for the author, Zhixing Wu, sorry if I butchered that, but I'm really appreciative of him and everything he's done. All his tutorials are really what got me started on using Python and Earth Engine for satellite image processing, and really changed the way I see approaching remote sensing processing. So mad props to him. And also worth pointing out the Geospatial package, which really is just a way to install a bunch of great geospatial packages in just one go, including Geemap. And I've tested installing both Geospatial or Geemap alongside RadGEEtoolbox, and they work beautifully together. And hopefully I can get RadGEEtoolbox involved with this Geospatial package. But just wanted to point that out because now we're about to be using Geemap to create the map to visualize this data. And all we have to do is say map add layer, just saying col.imagegrab -1 to say we want to get the latest image in the collection. And then we define the visualization parameters here using the visparams function. So doing so, look how fast that loads. Amazing. And you can see it's mosaicked. So we have two tiles here mosaicked into one, covering like a third of Utah. Now let's do the same for the NGWI image. So we say NGWI image grab and get the latest image. And then in this time we specify it's the NGWI as the index, not true color. And we decided to specify a min and max value of our own to override it. And then here's an example of how to get a color bar. So you would use the visparams function to also get a color bar. So it makes it really easy to get to visualize everything you need. So now we're seeing, oh, there's the Great Salt Lake. Oh, here's Utah Lake. And here's a bunch of other water bodies throughout northern Utah and central Utah. And then we can see the color ramp that we used here and how it's got stretched. So that's beautiful. And very few lines of code needed. Let's do the same for the land surface temperature. So you can see that these are the stock palettes and you can change the palettes if you want, but I tried to make them pick good palettes. And so this shows the land surface temperature at this time. We're really hot. Really hot, and that's the latest image in the collection, so it was probably late July. And now let's look at the mean surface temperature. So really easy way to just look at mean surface temperature from a whole collection. And let's look at a chaining example of kind of pulling it all together once again. So let's define a Landsat collection for certain dates, certain area, and then in the same line, let's mosaic it by date, and let's mask to water, and then let's calculate turbidity, and then let's grab the last image, let's get the info for that last image, and then let's plot it. So I just want to show how fast this works. Yeah, so, okay, we took 3 months of images, multiple tiles, we mosaicked them, masked them, and did a multispectral calculation, selected the last image in 0.6 seconds, and then put it on the map in 0.7 seconds. Showing turbidity in the Great Salt Lake, showing turbidity in Utah Lake. This is a real area that has a lot of turbidity problems. So yeah, this is just kind of showcasing that it works really well with straight up Earth Engine API data, but also interfaces very well with Geemap. And I hope this has kind of helped give a good background and motivation of why you might want to use this package and how to use it. And in the future, I hope to put some more videos up that goes over some more functionality and just more so showcases why this package is cool and why I'm really happy to be putting this out there, and why I'm also just happy that I have it to use myself, because I'm constantly looking at different image collections from all over Utah for different reasons and calculating different multispectral indices, and this makes it a lot less messy. So thank you so much. And again, if you need any more information, please visit my GitHub page. Please message me. And thanks for watching.